Thanks a lot. Good morning, everyone. My name is Prateek Katiyar, and I have a background in machine learning and medical imaging, and I'm presenting here on behalf of Nicholas Kelly, who is generally a regular at AMLD, and the entire AI Innovation Lab. It's a very short presentation, so I'll try to give a general overview of ML space at Novartis, as well as give you some concrete examples, technical examples. I know you might be tired of seeing such corporate slides, but I would like to show you these numbers again because truly Novartis's broad outreach to patients was one of the reasons why I actually joined the company. And what is more important to know that Novartis has a strong focus on innovative medicines. So if you're doing machine learning there, you really have a chance to work on one of the most cutting-edge therapies from the industry, such as gene therapies, radioligand therapies, and this also applies to the domains on which you can apply machine learning. So you can work on more exploratory, research-heavy problems from the preclinical domain, or you can work on real-world data sets that are acquired from clinical trials, all the way to process optimization. So the AI and machine learning ecospace at Novartis has a strong focus on community and education. So that's why we also have a year-long AI residency program in which we work with university graduates, so both master's and PhD graduates. And the students, they get to work with domain experts from different business units, and we also get to learn from their knowledge about state-of-the-art ML. I come from the innovation lab where we focus primarily on AI problems or machine learning problems that create business value. So I come from the computer vision team, and I'd like to give you an example of domain-specific representation learning direction, which is one of the very important topics in the vision team. So what you see in the panel is a histopathology model named as HistoNet, which has been very recently published in 2 of the articles. And by analyzing the representations of HistoNet, what we realize is that for any downstream tasks that are domain-specific, let's say so downstream tasks for the histopathology domain, the representations of the HistoNet model are extremely rich and a lot better as compared to general-purpose representations that you might extract out of natural image models, for example, models trained on ImageNet. So let me give you some of those problems, downstream problems. So one problem is deep one-class classification, where you'd like to do anomaly detection. In particular, if, let's say, you're using contrastive loss, which induces the property of uniformity for your inlier data distribution, using domain-specific representations we have found to really improve the performance of the anomaly detector. Another problem that we solve is perceptual image quality assessment. Distribution shifts are extremely common in the healthcare domain, and one way to detect distribution shift is by doing perceptual image quality assessment, and deep features have been extremely effective at this. So instead of using ImageNet features, we have noticed that if we use domain-specific features, we can do a way better assessment of image quality. Lastly, we also work on time series modeling problems. Most of the time, for these time series modeling problems, the trajectories of different patients are not synchronized. Also, these are mostly problems in which the number of samples is extremely low. These are also problems where the dimensionality bottleneck is very high. So generally, the inputs are extremely high dimensional, and the output is very sparse and low dimensional. So here also, we have found that using pre-trained models on that particular domain actually solves the problem a lot effectively than using ImageNet models. So this is just not applying to histopathology domain, so we are also doing this in other imaging domains as well. And eventually, we'd like to go in the direction of more symbolic feature extractors by incorporating, let's say, knowledge from clinicians, but we're not there yet. So with that, I'd like to thank you for your attention, and please reach out to me if you have any questions.